I want to solve a kinematics problem for you. And so let's consider the following. Let me get my problem here. Let's consider that we have a skier. And can we see this? He's skiing down a slope, right? He's starting from rest, right? So I'm going to say his velocity up here is 0. He's starting from rest, and let's say he accelerates in a straight line at a rate of 2 meters per second squared. And let's say he does this for 7 seconds. Right? He does this for 7 seconds, and I want to know how fast he's moving down here at the bottom. I want to know how fast he's moving. Okay? So let's go through our process and see what's happening here. I'm going to use the guess method to solve this problem. And remember, the first thing that we have to ask ourselves when finding out about acceleration problems is there acceleration? Okay? Is there acceleration in this problem? Well, the problem says he accelerates down the hill, so yes, there's going to be acceleration. If there is acceleration, we write our variables up here. Okay, the variables for the kinematic equations are AT, VVD. Remember we said that in class? So AT, V, the first V is VI, the second V is VF, and delta D. AT, VVD. I hope you can see that. I think you can. And I'm going to ask myself, do I know all these variables? Do I know A? Well, yes, I do. I was told that he accelerates at 2 meters per second squared. So that's my acceleration. Do I know the time? Yes, I do. The time is 7 seconds. Do I know the initial velocity? I do. Initial velocity is 0. Do I know the final velocity? No, I don't. I'm not given that in the problem. In fact, that's one of the things that I want to find is the final velocity, the velocity at the end of the run. Do I know delta D, the distance? No, I do not. I'm not given that. I'm going to transfer these two down to here because these are my two unknowns. I don't know VF and I don't know delta D. So now I have two unknowns, and if you remember right, let's talk about how we pick an equation if we have two unknowns. You have your equation sheet here, okay, and you have to look at it. Maybe you can see this. You have to look under the equations of constant acceleration 4 through 7. I know that's not focused, but you need to find an equation that has the one that you want, and the one that you don't want. So the question is, we have to figure out what is the problem asking for. We know that they want the velocity at the end. That's the final velocity. So I'm going to circle that one. That's the one that I want to find, final velocity. And if I want to find final velocity, I'm going to cross out the delta D. This is my I don't care variable. I don't care about that. I'm going to find an equation now that has final velocity and not delta D in it. Okay? And that equation happens to be VF equals VI plus AT. Now I want to show you something. And don't write this down if you're writing. But I want to show you that let's say that you looked here on your equation chart and you thought, ooh, number 2 has VF in it. Let's do number 2. Well, number 2 says delta D equals 1/2 VF plus VI times T. Okay, there's equation number 2, 1/2 VF plus VI times T. So we're going to plug everything into that we know, everything that we have up here at the top. So plug in. Here we go. Delta D we don't know, so that's going to remain as an unknown. 1/2 VF, we don't know it. VI is 0. Time is 7. Okay, there we go. Now I can simplify 7 times 1/2. That gives me 3.5. So delta D is 3.5 VF plus 0. And I can distribute that through here, and that gives me delta D equals 3.5 VF, because 3.5 times 0 gives us nothing. And now we're at this point. What do we do next? Well, you might say, well, divide by 3.5. Okay, let's try that. Divided by 3.5. All that gets me is delta D over 3.5. It doesn't give me a number. Here's the point. You can only have one unknown in your equation after you substitute. Here's my substitute step. I've substituted everything in, and I have 1, 2 unknowns. This is not good. You cannot have 2 unknowns in your equation. If you do, you'll get here, and you won't be able to solve for it. But you know what? That's okay, because that's what erasers are for. So you realize this, you're like, wait a second, I have 2 unknowns. Erase that. I picked the wrong one. Oh, I remember. My equation cannot have the unknown that I don't want. So we go back and we see this one, because this one has VF and not delta T. And now we can go and plug in and solve. So VF equals VI is 0 plus A is 2, and the time is 7 seconds. Let me pause here because I forgot to tell you something. Up at the top in the G section, there's something that I need to do, actually 2 things that I need to consider before I ever move on. The first one is conversion, and the second is direction. Conversions, I want to look at all my units and say, are they okay? Are all my units okay in this? Well, the only numbers that I have, the units are okay, so I'm not going to do any conversions here. The second is direction. Well, let's think about direction. If he's moving down this slope, he's going to accelerate and he's going to speed up. And if we give him a positive velocity, he'll need a positive acceleration to speed up. So it's correct that we wrote this in positive. The direction of these things will come in a little bit more later on in another problem. But we can solve this. This is real easy to solve now. 0 goes away. 2 times 7 is 14. So the final velocity of this skier is going to be 14 meters per second.